Last week.
It's the user.
I think the small one. So you know something. Actually.
Check the my pen is there. Check the very well. My pen is supposed to be there. Moving test. Pen that I drop this pen just now. Yo, as me detail. Audio. Àwọn ṣe ṣẹ̀nẹ̀ dú ẹnikẹ́ni náà wọ́n bá kó kó táwọn tèmi wọn ta. Ẹ tèmi bá ẹ wọ́n táwọn kẹ̀dọ̀ wọ́n lára wọn pé tẹ̀wọ̀n bí orí ká. Adam, it's online test o. I swear. It's not even like it's test, but you do it as written test. Sure. Yeah, I was feeling as it's like image scenes. I think they say it's tutorial now. I don't really know why. Let me just do it so that I don't turn something from my head. The person has start.
Okay, welcome everybody. So today we'll be looking at elementary mathematics with various topics, starting with ray sequence and series, that is the APGP, harmonic series, and the quadratic series. Basic set operation, elementary theory, quadratic equations, set of numbers, mathematical deductions, and complex numbers. So these are some of the topics that elementary maths. Although they have different names depending on the school. So today we are going to be looking at various questions that are, I adopted this question from a different school. Let's see how we can deal with each and every one of them. And at the same time, feel free to ask us questions by the end or the process of doing the class. This is a YouTube channel. We just trying to help students. We call it STEM Up Africa. Please help us to subscribe if you have not done so. That's the only way you can support us. We are not asking for money, just your support by pressing the subscribe button. So, if you have any question before we start, you can ask. I'm giving all of us 2 minutes to do so.
No.
Any questions?
It's a lie. We should not talk anything.
Okay. In the absence of no question,
There's no question, but please let that person turn off their audio. The person is
okay.
disturbing.
Okay. All right. Thank you for notifying that. Please, if your audio is on, please off it so that other people can hear what is going on. Thank you. So you can join the meeting via Zoom, Facebook, or YouTube. So this is with the link given. So let's start with the first question. Like I said, we're going to treat general questions. If you don't understand anything, the course of doing it, you are very free to ask questions. Very free to do so. Like I said, this is our YouTube channel. We're trying to grow it. You can help us by subscribing. We treat a lot of subjects: physics, chemistry, engineering, maths, mathematics, technical drawing, computer studies, programming, what have you. We treat all those things in our channel. We are trying to broaden the scope by introducing even art subjects and medical subjects as well. So let's start with the first question that says the root of a quadratic equation is real. Well, at the same time, you can also invite your friend to join the channel through our STEM of Africa. So let's begin with the first question. You said the root of a quadratic equation is real when the discriminant is what? So let's first of all understand the concept of discriminants. Discriminant is obtained from a quadratic equation. That formula they call the almighty formula. That is where the discriminant is obtained from. So let's see how we can come up with it. Let's see how we can explain the concept of discriminants using the quadratic expression. Okay. Okay, so let me quote a quadratic formula that says if you have ax squared plus bx plus c is equals to 0. So from this expression, we are told that our x is minus b plus minus square root of b squared minus 4ac over 2a. So this formula we call the almighty formula or formula method in quadratic equation. So from here, they classify D, which is our discriminant now, as b squared minus 4ac, which is what is inside the square roots. It's classified as our discriminant. Now, there are 3 conditions for these discriminants. If D is greater than 0, for instance, maybe at the end of the day, if I substitute, maybe b is, let's say b is 9, our b square is 3, 3 square is 9, a and c is 1. At the end of the day, you have value of d greater than 0. We call this expression as real roots. It refers to as a real root. Each value is greater than 0. That is, you solve at the end of the day, the value of d you have is greater than 0, such as 1, 2, 3, if that's the value of D, we call that real root. Then the second condition is that if your D is equals to 0, is referred to as equal root. It's called equal root. That is what it's called. Then, if our D is less than 0, they call it complex roots or imaginary roots. Complex or imaginary. That is what it's called, complex or imaginary roots. So these are the 3 conditions for a discriminant value. So if you go back to the question, you will notice that the question 1 says the root of a quadratic equation is real. We're talking about real roots now. Where the discriminant is what? You can see the option is B, where the discriminant is greater than 0. So that's the concept of applying discriminants when you are dealing with real roots, imaginary root, or equal roots. That is the answer to that. Question 2 is similar to question 1. Say the root of a quadratic equation are imaginary. Where the discriminant is what? Let's go back and see imaginary. For imaginary roots, look at what we said. For imaginary roots, our D is less than 0. That's for imaginary roots. So that is for us.
Friends at a serious disadvantage.
If I go
Their
back,
next opponent is
you see that our answer
exactly what he plans to do in this match
is
is
less than
anybody's
0.
guess.
That is the answer to that question.
At the start
Question
of
3
the
says
third
solve
phase
the
of the Harvard
equation
exam, there were
x
4
squared plus 1 equals to 0. We are asked to find to solve means to find the unknown, and the unknown from the expression is x. How do we find x from here? So let's see how we achieve that. We are told x squared plus 1 is equals to 0. Please take notes. Before you can solve this, we'll take note of what we call a complex expression. I squared is equals to -1 from complex number. We are told that I squared is equals to -1. With that in mind, let's see how we can find x from here. By first of all, collecting like terms, I will invite 1 to this side. If I invite 1 to the right-hand side, it becomes minus. I'm going to have x squared is equals to 0 minus 1. X squared will give us minus 1. And what is minus 1? Look at this expression. Our minus 1 is what? Is I squared. So that means anywhere I see I squared, anywhere I see minus 1, I will put I squared. So I'm having x squared is equals to I squared. So what is that my x? X will give me plus negative. Anytime you're taking a square root, it must be either plus or negative. So what is square root of I squared is simply I. So my x is plus negative I. That's the value of x plus negative I. So let's see from the option which of them is correct. So you can see our x squared is either plus I or minus I, which happens to be option A, plus I or minus I. So I hope that is understood. So if you have any questions on what you have done so far, you are very free to ask before we proceed to question 4. Any?
Yes, sir. Yes, sir.
Okay.
Sorry, my question might sound a bit like
No. You are very free to ask. Like I said, this is just want to try to use to help students.
okay.
So you are very free to ask.
Okay, these questions we are solving now, what topic is it under? What topic?
Okay, this is under the root of a quadratic equation. Question 1, 2 are under the root of a quadratic equation. Question 3 is under complex number. Question 4 is under the root of quadratic equation.
Okay.
The root of quadratic equation, yes. No, you are very free to ask questions. This is an open class. You can ask any question. Okay?
Okay. Thank you.
Yes. There's no need for you to be sorry about it.
Okay,
You
sir.
are very free. Yes, you are free to ask. Okay. So number 4 is also the root of equation, root of quadratic equation. So let's see. It says if P and Q are the roots of the equation, what are the values of P and Q? If P and Q are the root of the equation, what are the values of P and Q? Now, when it comes to the root of the equation, the root of the equation are called alpha and beta. That's what we call the root of equation. Anytime you solve a quadratic equation and you have two answers, two values of x, the real name for them is not the values of x or the value of any variable. The real name for them is alpha and beta. Are you there? So they are telling us that the root of this equation are p and q. They are asking what is the value of p and q. That's what the question is telling us. So let's see how we can achieve that. They gave us x squared plus px plus q is equals to 0. The roots from the statements are p and q. Okay, so from our normal equation, we are told that we have ax squared plus bx plus c is equals to 0. So from here, I can get the value of a, b, and c. What the coefficient of x squared here is 1, even though we are not writing it. Coefficient of x squared is 1. So if I should compare now, x squared to x squared and a to 1, you can see that our a is 1. Then if I should compare the second value, you will notice that our b is p. And if you compare the last value, which is c, which is value without x, our c is q. Okay, so from that, we can now determine the values of p and q. They ask us from the equation. A minute, sorry. I want to check something. Sorry, a minute. So, sorry, I'm back. So let's compare now. If I compare the first variable, you agree with me that my a is 1. If I compare the second, x to x, where's my b now? My b is p. Then the value without x, my c is q. So the root, they said, is p and q. The root is p and q. So under the rule, we have sum of roots. Also, we also have products of roots. So the sum of roots is called alpha plus beta. That is sum of roots. Product of root is called alpha beta. And sum of roots, alpha plus beta, is simply minus b over a. That's the expression for sum of root. Minus b over a. While product of root is alpha beta, the value is c over a. Those are the two expression for sum of roots and product of roots. So now that we have gotten a, b, and c, if I put them into sum of root and product of roots, we are going to have alpha plus beta now, which is sum of roots, is minus p over 1. Because my b is p, while my a is 1. That will give us what? Minus p. While alpha beta is c over a, my c is q, my a is 1 also. The value is also what? Is also q. And don't forget, they said p and q are the roots, which represents that my alpha is p, my beta is q. They say p and q are the root of the equation. That means my alpha is p, my beta is q. So if I substitute p in place of alpha and substitute q in place of beta, what are we going to have? Let's put it here now. Let's put in the first expression, I'm going to have p plus q is equals to what? P. So from here, I calculate like things by inviting P to meet a fellow P. So my Q will give us what? P minus P, which is 0. So the value of Q now is simply 0. So let's also substitute the value of alpha and beta now into the product of root, which is alpha beta. Let's substitute them into the product of root alpha beta. So my alpha beta is simply Q. But then my alpha is P, my beta is what? Is Q, is equals to what? Q. So how do I find P from here? I can cancel both sides because there's Q on both sides. Q will cancel Q. That means my P is simply what? 1. Therefore, my P is 1 and my Q is 0. So let's go back to the options and see which of them could be our answer. My P is 1, my Q is 0. But we have a reverse case here. So what they have here is Q is 0, P is 0, and Q is 1. So most likely is a typical error. So in examination condition like this, as human beings, we are not perfect. There's bound to be error. So in examination like this, I will advise you go with option A. It's possible who type the question make a little mistake in the course of that. So in examination condition, go with the option that is nearly close to the real option you have, which is A. So for me, I will go with A, although A is not what we ought to obtain. So let's go to question 5 and see what the question says. Please a minute. So let's go to question 5. We are having a network issue here. Sorry about that. Let's go to question 5. The question says, if alpha and beta are the root of this equation, then find the equation. What is the equation whose roots are alpha square plus 2 and beta square plus 2? So let's first of all write the equation and determine the value of alpha plus beta, which is sum of roots, and alpha beta, which is the product of roots. So let's determine the expression from the equation given to us. We are given 2x squared minus 3x minus 6. So the equation given to us is 2x squared minus 3x minus 6 equals to 0. So if I compare with the original standard equation, which is ax squared plus bs plus c equals to 0. So if I compare this expression as x squared to x squared, that means my a is 2, x to x, that means my b is what? It's minus 3. Because here it's negative sign. That means my b is minus 3. Then if I do the same thing for c, which is the one without x, my c is minus 6. So from here, we determine the values of alpha plus beta, which is sum of roots, and alpha beta, which is product of roots. So alpha plus beta, it has a formula, which is minus b over a. That will give us what? Minus into, there's a minus here already. My b equally have minus. That will become what? Minus 3, minus into minus 3 divided by what? A, which is 2. Minus minus is plus. That will give us 3 over 2. 3 over 2 now is simply the value of the sum of the roots, which is alpha plus beta. What about the product of roots? Alpha, beta. The formula is C over A. Where's my C? Minus 6 divided by my A, 2. That will give us minus 3. So the value of alpha, beta, which is the product of roots, is minus 3. So now that I've gotten this, let's go back to the question. It said we should form a quadratic equation that the roots are alpha squared plus 2 and beta squared plus 2. So let's form the equation now. But what is the formula for obtaining an equation? The formula is this: x squared into sum of roots plus product of root is equals to. That is the formula looking for quadratic equation. If the roots are given, product of roots equals to 0. But we are told that the roots are alpha squared plus 2 and beta squared plus 2. These are the roots we are asked to form the equation with. So from these two roots now, I will get the sum of the roots. Sum of roots. Sum of the root, I mean, I will sum these two guys together. I will sum this at this because these are the roots, which is alpha squared plus 2 plus beta squared plus 2. So I will add those I can add. I can add 2 and 2 together. That will give us 4. So I can rewrite this as alpha squared plus beta squared plus 4. But if you go back, we have values for alpha plus beta and alpha beta. We don't have value for alpha squared plus beta squared. So the next question you should ask yourself, how will you express alpha squared plus beta squared in terms of alpha plus beta and alpha beta? So that should be my target. So how will I express this expression here now to contain alpha plus beta and alpha beta? So let's see how we can express that. So my alpha squared plus beta squared plus 4 can be written as alpha plus beta all squared minus 2 alpha beta plus 4. This value here, this whole value here represents this. This whole value here represents this. Your alpha squared plus beta squared can also be called alpha plus beta all squared minus alpha beta plus the original 4 that was there. So I can now substitute my value. In place of alpha plus beta, I have 3/2 minus 2 times alpha beta is now 3 plus 4. 3 minus 3, I mean. Minus 3 plus 4. So here will give us 9/4. That will give us plus 6 plus 4. If I sum these two up, that will give me 10. I'm having 9/4 plus 10. So I can take LCM here. LCM of 1 is 4. At the end of the day, our sum of roots that will give us 49 over. That is not the value of alpha squared plus, that is sum of the root now. So let's also get the product of the root because the formula contains sum of roots, product of the root. We have gotten the sum of root now as 49/4. Let's also get the product of root from these two expressions. Let's get the product of the root. So product of roots, I will write product of roots. Product of roots will give us alpha squared plus 2 times beta squared plus 2. So as we expand, that will give us alpha squared beta squared plus, this will also multiply to 2 alpha squared multiply to beta squared plus 4. So if I should apply the law of indices to these two, if I apply the law of indices to this, I can write it as alpha beta all squared plus, I can factorize 2 from here. 2 bracket alpha squared plus beta squared plus 4. So, but we don't have expression for alpha squared plus beta squared. So I will also express it the way I expressed the previous one for alpha squared and beta squared. Alpha squared and beta squared is this. So I was expressing it as that. So I'm going to have, we're going to have coming. Okay. Okay. This is where we are now. So my alpha square plus beta square, I will replace it with that expression. So if that should happen, I will have alpha beta all squared plus 2 into alpha plus beta all squared minus 2 alpha beta bracket close plus 4. So now I can substitute my values that I've gotten from alpha beta and the alpha plus beta. So alpha beta was minus 3 we got. That become minus 3 squared plus 2 into alpha plus beta was 3 over 2 all squared minus 2 times minus 3 plus 4. If I simplify, that will give me 9 plus 2 brackets. Here is 9 over 4 plus 6 plus 4. So which is 9 plus, that will give us 9 over 2 plus 12 plus 4 plus 4. That is, if I should use the 2 to open the bracket, will give us 18 over 4. 18 over 4 is 18 as 9 over 2. The 2 times 6 is 12 plus 4. So if I should add up, here will give us 12 plus 4, 16 plus 9, that is 25 plus 9 over 4. Then if I take LCM here, the LCM should be 4. I'm having 100 plus 9, which is 109. So the product of the roots now, product of roots will give us 109 over 4. So now that I've gotten the sum of root and product of root, let's substitute it into the formula now. X squared minus sum x plus product is equals to 0. I'm having x squared minus 49 over 4x plus 109 over 4 is equals to 0. So here's over 1. I can take LCM. The LCM will be 4. So if I take the LCM, at the end of the day, I'm going to have 4x squared minus 49x plus 109 over 4 equals to 0. Yes, over 1, if you cross multiply, you are going to have 4x squared minus 49x plus 109 equals to 0. So this is not the answer for the root of the equation. Although this question is very complex, it's a very, very complex question. Yeah, very complex. So what we got was 4x squared minus 49x plus 1, was it 109? 4x squared minus 49x plus 109 equals to 0. So although we don't have 109 there, I don't know, let me check again. Is it 109 we got? Yes, 109. This is 16 plus 9. That is 25. That is 25 times 4 is 100. So it ought to be 109. Yes, I'm right. Ought to be 109. Though there's no 109, but the one closer is our B. B is 4x squared minus 49x plus 118. Ought to be 109, not 118. So that's the solution to the question on the root of the question. If you have any question, you are free to ask. Any questions so far? So if there is none, we go to question 6. Then we might go to question 6. A minute. So let's go to question 6. This question 6 is a complex number. It's a complex number. Say if x plus 3 plus a complex expression, which is that I, into y minus 2 equals to 5 plus 2i, we are asked to find x and y. So this question is very simple. All you need to do is to arrange the left-hand side to look like the right-hand side. That's all it takes. Arrange the left-hand side to look like the right-hand side. We have real numbers and we have imaginary number. The 5 is a real number, while the 2i is an imaginary number. So we arrange them according to the way they ought to be. Okay? That if it's not arranged, it's expected that you arrange them. So let me write this expression and see. X plus 3. We're having x plus 3 plus r into y minus 2 is equal to 5 plus 2i. Now, if you look at this expression, it's already been arranged. The x plus 3, they are the real number. This one is real. This one is real number. This one is imaginary or complex. Imaginary. The 5 is also real number. The 2r is imaginary. So it has been arranged already. So when you have a situation like this, all you need to do is to compare both of them. Real number to real number, imaginary number to imaginary number. So that means I will compare the two real numbers. What are the two real numbers? X plus 3 is equals to 5. Both of them are the real number. So from here, I can get my x by collecting like terms. My x is now 5 minus 3. That will give us. So I will also compare the imaginary. These two now, they are the imaginary. This and this represent the imaginary. Please, yeah, unmute. If you are not asking questions, please unmute your microphone. Unmute your microphone if you are not asking questions. So let's compare the imaginary. We are having y minus 2 is equal to 2. I can collect letters from here. My y becomes what? 2 plus 2. That is 2. Our x is 2. Our y is 4. Let's see which of the options satisfy that. Our x is 2. Our y is 4. That is option A. That is option A. Our x is 2, our y is 4, option A. Then question 7 is also a complex number. They give us Z1 as 2 plus 3i, and Z2 is 5 plus 2i. We are asked to find Z1 minus Z2. So let's write both of them. Our Z1 is 2 plus 3i, our Z2 is 5 plus 2i. Let's write both of them. Z1 is 2 plus 3i. Z2 is 5 plus 2i. We are asked to find Z1 minus Z2. We're asked to find Z1 minus Z2. So all I need to do is to substitute. Every I see Z1, I will write 2 plus 3i. Every I see Z2, I will write 5 plus 2i. So let's do that. In place of Z1, I will have 2 plus 3i minus Z2 now is 5 plus 2i. So from here, I will use negative sign to open the brackets. That will give us 2 plus 3i. The minus side will affect 5 to give us minus 5. The minus 5 will affect plus 2i will give us minus 2i. So I will add those I can add. You can only add real number to a real number. You can only subtract imaginary number from imaginary number. So if I add the two real numbers, which is 2 and 5, I subtract them, 5 from 2 will give us minus 3. Then 3i minus 2i will give us plus 1i or I. 1i is taken as I. So the answer is minus 3 plus I. Minus 3 plus I, which is option D. Minus 3 plus I, that's option D. So I will leave question 8 for you to solve. It's similar, but this time around you are adding. I will leave question 8 for you to solve, but this time you are just adding. I think you'll be able to figure that out. Then question 9 also is also a complex number, but this one involves an argument and modulus. Argument and modulus. We are asked to convert the real and imaginary number to complex form. The real and imaginary number to complex form. So how do you do that? So I have Z. According to you classify Z as 1 plus I. So I'm going to put these two expressions into an Argand diagram. This has also been written as X plus IY. X plus IY. That means the X is the horizontal, while the Y is the vertical. That's what it means. So if you compare these two now, meaning my X, this is the X axis, while this one is the Y axis. So if I compare now, meaning my S is 1, if I compare this, meaning my Y is also, there's variable here 1, here we are not writing it. Our Y is also 1. So here is 1, here is 1. So I will now find the modulus. I'll take the modulus from here now. Let's call the modulus absolute Z. Let's call the modulus now. The modulus is always represented as absolute. So I can form a right angle triangle here to have here as my angle theta. So if here is 1, if here is 1, here is also 1. So to find the absolute value, I will simply apply Pythagoras theorem. That's the only way I can get the absolute value. So let's call it R or Z or R. So let's use R to find the absolute value now. So R squared give us 1 squared plus 1 squared, which is 1 plus 1. That will give us 2. So my arrow now, which is the square root of 2.
It's in no angle.
Okay. So my arrow now is the square root of 2. So from there I can get my theta by using SOHCAHTOA to get my theta. If I apply SOHCAHTOA, that should be able to give me theta, which is opposite and what? Adjacent. Opposite adjacent is tan. That will enable me to get my theta. So I will have tan theta is equals to 1 over 1. That is 1. Where's that my theta? Is the arctan or the tan inverse of 1. Tan inverse of 1 is 45 degrees. So if I want to put it in polar form, the expression for it is Z is now R into cos theta plus I sin theta. This is the expression in polar form. Z equals to arrow bracket cos theta plus I sin theta. So let's substitute it. My arrow is square root of 2. My theta is now 45. And you are see arrow, put square root of 2. And you are see theta, we put 45. So my Z will give me root 2 into plus 45 plus I sine 45. 45 is a special angle in trigonometry, and the value is 1 over root 2. That's the value of sine. Sine, of course, 45. So I'm having Z as root 2 into 1 over root 2 plus I times 1 over root 2. So I can use root 2 to open the bracket. If that should happen, I will have root 2 over 2 plus I root 2 over 2. So over root 2, I mean. Except they leave the answer in this form. They leave the answer in this form, fine. But if they leave it in this form, you can decide to simplify it further. Let's check which form the answer was left. They left it in polar form, which is root 2 brackets cos 45 plus sine 45 plus I sine 45, which is option C. That is the value. Root 2 bracket, open bracket cos 45 plus I sine 45. That satisfies option C. Then number 10 is also a complex number. Say in z equals to 4 plus I, what is the imaginary part? I told you for every complex number, we have real and imaginary. The real is the 4, while the imaginary is the I. But what is the coefficient of I there? That's the question you should ask yourself. What is the coefficient of I there? Coefficient of I should be 1. You're giving z as 4 plus I. This is imaginary. That's what you're asking us to find, imaginary. Why this 4 is the real number. So the coefficient of 4 here is 1, although we are not writing it. Coefficient of 4 here is 1. So the coefficient of the imaginary number is simply 1. That satisfies option B. Please, sorry, we are having a network problem here. We're having a network problem here, so just give us a minute. I'll come back so that we can fix a minute. Come back to fix the other questions. But if you have any questions so far, you are very free to ask. Please stop writing on the board. Please, you can erase it. Help us erase it. Erase what you have written. Okay, let's continue. Please, if you wrote anything, help us erase it. Let's go to question 11. So find the modulus of the complex number 1 plus 2i divided by Okay. We are back. So let's go to question 11. We are asked to find the modulus of the complex number. The modulus is also called the absolute value of a complex number. So let me write the expression and see how we can fix that. Sorry for the break in transmission. So let's see. Let me rewrite the expression. Let's see how we can get the modulus of this. We are given 1 plus 2i, 1 1 plus 2i over 1 minus 1 minus I. This is the expression we have. So what I will do in this case, I will just let the minus sign here to open the brackets. I will allow the minus sign in denominator to open the bracket. If that will happen, then I'm going to have 1 plus 2i over 1 minus 1 plus I. Because minus will give me plus. So I will have 1 minus 1 plus I. So minus 1 plus 1 is 0. I'm just left with 1 plus 2i over I. So I can use the I or rationalize it. I can rationalize the I, the denominator, so that I can have a simple expression, because a little bit complex as it is. So let's rationalize the I. I'm going to have 1 plus 2i times I over I times I. So if I expand, I times 1 will give us I plus 2i times I will give us 2i squared over I squared. Remember what we said earlier, that I squared, our I squared is simply minus 1. That's what we said earlier when we were creating the first complex number. So I'm going to have I plus 2 bracket minus 1 over minus 1, which is I minus 2 over minus 1. So in minus 1, if I divide the numerator by minus 1, minus 1 will affect each of these 10. That will give us minus I plus 2. So now that it's more simplified, I can now look for the modulus. The modulus is the absolute value of this expression. This will give us square root of minus 1 squared plus 2 squared, which is square root of 1 plus 4. That will give us the square root of 5. That's not the modulus of the expression. Let's go back and see which of the option is correct. Yes, you can see there is option D. The answer is square root of 5. So let's look at question 12. It's also a complex number. Now, it says if, open bracket, 1 plus I, open bracket, x plus iy equals to 2 plus 4i, then 5x is what? So let's first of all expand the bracket given to us, and we arrange the real number and the imaginary number to each other. So let's do that. We're going to have, they gave us 1 plus I plus x plus iy is equals to 2 plus 4i. Equals to 2 plus 4i. We are asked to find 5x. So when I have a situation like this, the first thing I will do is to open the bracket. But when doing that, don't forget what to say is I squared. I squared, we said the value is minus 1. So let's expand the bracket. 1 times x will give us x. 1 times iy will give us iy plus I times x will give us ix. While I times I will give us I plus I square I equals to 2 plus 4i. I square we said is minus 1. So I can replace this with minus 1. So I'm left with x plus iy plus ix minus y is equals to 2 plus 4i. Now, if you look at the left-hand side, we have I. So I'm going to group the I as 1. I'll group the I as 1. Why I will arrange x to y, because both of them are real. Real number, they don't have the I. That's why we call them real number. So I will have x minus y plus, I is coming from these two, I into x plus y is equals to 2 plus 4i. All I need to do is to compare coefficients, real to real, imaginary to imaginary, on both the left-hand side and the right-hand side. Who's the real number on the left-hand side? It's x minus y. Who's the real number on the right-hand side? Is 2. So let's do that. We're having x minus y is equals to 2 Then let's also compare the imaginary. That means x plus y will give us 4. Because in the left-hand side, the I bracket, x plus y is imaginary. On the right-hand side, we have 4i. So let's compare both of them now. We are going to have x plus y equals to 4. So we have x plus y is equals to 4. I call this equation 1. I call this equation 2. So you can solve equation 1 and 2 now simultaneously by looking for x. Our interest is x. We are asked to find 5x. So I need x to get 5x. So this is two equations. I can solve that by saying adding equation 1 and 2 because the y is negative. If I add both of them, it will just give me 0. So I will write add 1 and 2. So as you add 1 and 2, x plus x will give us what? 2x. Y plus y will just blow up to 0. Then 2 plus 4 is 6. My x is now what? 6 over 2. That will give us 3. Then we are asked to find 5x. So my 5x will be what? 5 bracket 3. That will give us 15. Our answer is simply 15. That is the solution to the question. Our answer is 15. That happens to be option C. That is option C. Question 13 is similar to question 11 we just did. We are asked to find the modulus. What I will do, if the expression given to you have a fraction, the first thing you do is to rationalize it. The denominator. So let's see how we can achieve that to get the modulus. Let's rationalize it. We are given 4 plus 2i over 1 minus 2i. So if I rationalize, I'll rationalize by looking for the conjugate of the denominator. For the conjugate means the negative value becomes positive value becomes negative. So now that we're having negative value, if I'm rationalizing, it becomes positive. That means times, let's rationalize now, 2 plus I. 2 plus I now the conjugate. It's not a positive value over 1 plus 2i also. This is the way to rationalize from the idea of surd in mathematics. This is the way to rationalize. Don't forget, we said our I square is what? Minus 1. Don't forget that. So let's expand the numerator and the denominator. So if I should expand, 4 times 1 will give me 4, plus 4 times 2i will give me 8i. 2i times 1 will give me 2i. 2i times 2i will give me plus 4i squared over 1 time, here is the difference of 2 square, 1 square minus 4 square I. Don't forget what we said about I square. I square is minus 1. Then I can add these two guys because they are the same. I can add both of them together. So that will give us 4 plus 10i plus 4 bracket minus 1. Place of I square now, place of this I square now, I'm putting minus 1 in place of this I square. Then the same thing I will do here, I'll put minus 1 in place of this I square. 1 square is 1 minus 4 bracket minus 1. What would that give to us? 4 times minus 1 is minus 4. So minus 4 and 4 will just give us 0. So I'm left with 10i, just 10i over 4 times minus 1 is over 5. That will give us what? 2i. So we are looking for the absolute or the modulus value of 2i. That will just give us square root of 2 all squared, which is square root of 4. Our result is 2. So let's see which of the option is that, which is option C. Our result is 2. Question 14 is similar to question 13 we just did, but this time we are not looking for the modulus. They just ask you to rationalize by looking for the conjugate. So I will leave that for you to solve, rationalize what you have there, and see what your answer could be. Now, it says find the square root of what? Minus 7. Ideally, if you press calculator now, square root of minus 7, it will give you error. So how do you find the square root of minus 7? From calculator, we are going to have an error. So let's see how we can simplify that. Square root of -7. I can write -7 as -1 times 7. It doesn't change anything. It remains as what? -7. But from complex number, we are told that I square is what? -1. So that means if I see -1, I will put I square. So this will give us square root I square times 7. So if I apply the law of sort, that will give us square root of I square times the square root of 7. I can take that square root individually. I square will now give us what? I and what? Root 7. So square root of -7 is I root 7. Let's go back and see which of the option is correct. That is I root 7, which is option A, is the correct option. Then question 16 is just a simple expansion. I will leave that for you to solve. It says open bracket minus I into 8 plus I. All you need to do, use the I minus I outside to multiply what is inside. While doing that, don't forget the value of I squared. I squared is what? Is -1. Don't forget that. That will help you to determine the answer. It says they're asking now what is the nature of the root? 2x squared minus 3x plus 7. We are back to root of quadratic equation again. What is the nature of the root? I described the nature of the root for you the other time. There are 3 conditions. When our discriminant is greater than 0, we call that real root. When the discriminant is equal to 0, we call that equal root. When the discriminant is less than 0, we call that imaginary root. So let's see how we can determine to know the nature of the root, whether it's equal root, complex root, or real root. Complex root is also called imaginary root, and the real or what is real root, or is none of the above. Let's see how we can achieve that. They gave us 2x squared minus 3x plus 1 is equals to 0. Our discriminant, d greater than 0, we call that real. D equals to 0, we call that equal. Then D less than 0, we call it complex or imaginary. Referred to as complex or imaginary. So what is the expression for D we said the other time? We said our D is what? B squared minus 4AC. That's the value of D. So if I should compare variables now from our quadratic equation that says AS squared plus BS plus C is equals to 0. So if I should compare that now, you agree with me that my A is 2, my B is what? -3, my C is what? 1. So let's substitute these values now into our discriminant to determine the nature. Let's substitute it. Anywhere I see A, I will put 2. Anywhere I see B, I will put -3. Anywhere I see C, I will put 1. If that should happen, what do we have? I'm going to have -3 all square minus 4 d equals to now 4 times 2 and 1. 4 times 2 and 1. So d will give us what? -3 squared is 9 minus 8. What is the value of d now? Is 1. So the value of d, it means that our d is what is greater than what? 0. That means it's a real root. It's a real root. So that was the condition we stated earlier. If this is greater than 0, it's a real root. 1 is greater than 0, so we can call it a real root. So number 17, the answer is real root, which is option C. Is real root, which is option C. Number 18, we are asked to find the minimum value of the root. So here we are back to quadratic equation also. You are asked to find the minimum value of the root. This is also simple. We also use the discriminant value to determine the minimum value. We use the discriminant value to also do so. I know the discriminant value states that d equals to b squared minus 4 is AAC. B squared minus 4AC. So let's see how we can achieve that. The equation is given to us as 2x squared minus 3x, 2x squared minus 3x plus 1. So we have y, 2x squared minus 3x plus 1 equals to 0. 2x squared minus 3x plus 1 equals to 0. So how do we get our minimum? The minimum is y minimum is 4AC minus b squared divided by 4a. This is how you determine the minimum. 4AC minus b squared over 4a. So if you compare as squared plus bs plus c, as squared plus bs plus c, you agree with me that our a is 2, our b is minus 3, our c is 1. So if I fix it into this expression, what are we having? 4 times my a is 2, my c is 1, minus my b minus 3 squared divided by 4 times 1, which is 8 minus 9 divided by 4. Our answer is minus 1 over 4. This is the minimum value, minus 1 over 4. Let's check our option. My option, we have minus 1 over 4. Where is it? Nature of this road, okay. I can't see it. 2x squared, okay. Then that's, oh, I wrote the wrong equation. I'm supposed to write x squared minus 3x plus 4. Let's take that again. Supposed to have x squared minus 3x plus 4. So y minimum equals to 4ac minus b squared over 4a. We're having x squared minus 3x plus 4. Let me verify that once again. X squared minus 3x plus 4, yes. So let's see what minimum will be. So my a is 1, my b is minus 3, my c is 4. So I'm having 4 times 1 times 4 minus 3 squared over 4 times 1, which is 16 minus 9 over 4. 16 minus 9, that should give us 7 over 4. So our answer is 7 divided by 4. No answer from that question, no answer at all. Supposed to be y, not x, except they are asked to find the minimum of x, not the minimum of y. I have to find the minimum of x. From the expression, now they look for the minimum of x and not the minimum of y. So how do you get the minimum of x? The minimum of x, the question ought to be minimum of y, not x. The minimum of x is x minimum is minus b over 2a. That is x minimum. That is the formula for x minimum minus b over 2a. So my b is 3, my a is 1. So let's get that. I'm having minus into minus 3 over 2 times 1 is now minus 3 over 2. So our x minimum is minus 3 over 2. And that happens to be, let me see, it's 3 over 2, not minus. And that happens to be option A, 3 over 2. Then number 19, say if x squared minus 3x plus 1 equal to p, open bracket, x minus 3 has equal root. I gave the condition for equal root the other time when the discriminant is equal to what? 0. where the discriminant is equal to 0. That's why we have equal roots. So let's see what our expression, let's simplify this. We are given x squared minus 3x plus 1 equals to p into x minus 3. See, is a real root. Sorry, not real, but equal. Is an equal root. Equal root. So, you know the expression says that d is equals to b squared minus 4ac. So when d is 0, then we say is what? Is as an equal root. So that means every I see d, I'm to impute 0. But before then, I need to get the value of a, b, and c from the expression given to us. I need to get the value of a, b, and c from the expression using the normal or the standard quadratic equation. So let's rearrange this. I'm going to have x squared minus 3x plus 1 is equals to, I will open this bracket. That will give us what? Px minus 3p. So all I need to do now is to collect like terms by transferring p and 3p to the other side. So if that should happen, I will have x squared minus 3x plus 1. Then if I'm bringing in px, become minus px. If I'm bringing in minus 3p, become plus 3p. Nothing left here, 0. So I can group these 2p together because both of them have x. I can group these two together because they have x. So I'm going to have x squared minus 3x minus px. Then these two, I'll group them because they have no x. 1 plus 3p equals 0. So what is common from these two brackets here? X is common. So we have x squared into 3 plus p x plus 1 plus 3p is equals to 0. So now that I've arranged that this, I will compare it to the standard equation, which is ax squared plus bx plus c is equals to 0. So if I compare now, my a is 1, my b is now minus into 3 plus p, and my c is now 1 plus 3p. So my a equals to 1, my b is equals to minus into 3 plus p, and my c is 1 plus 3p. So I'm having d equals to b squared minus 4ac. For the root to be real, mean my d is 0. I will substitute now. And I will now put b in place of b now, which is minus into 3 plus p all squared minus 4 times a times 1 plus 3p. So if I square this, minus how will affect, the square will affect this minus. I'm just left with 3 plus p all squared minus 4 into 1 plus 3p is equals to 0. Because 4 times 1 will give us 4. So I will expand this. I need to expand this into 2 because it appeared twice. That means I'm supposed to have p plus 3 into p plus 3. So if you expand that, you're going to have p squared minus 6p plus 9. You can try that out. If you expand it, will give you that. Then I will use minus 4 to open the bracket. That will give you minus 4 minus 12p. Minus 4 minus 12p is equals to 0. So if I rearrange by adding p and p, I'm going to have p squared minus 18p plus what do I have there? Plus 5 is equals to 0. That is what we are left with. Plus 5 equals to 0. That is what we are left with as at, yes, that's what we are left with. So all you need to do is to factorize this expression. What can you multiply to give you 5? You add up, it give you minus 18. Okay, you multiply to give you 5. If you add up, it give you 18. Okay, that's what you are left with. Okay, well, you're supposed to be plus or minus, so I'm going to make some corrections. You're supposed to be plus, then you're supposed to be minus 6. You're supposed to be minus 6. Minus 6, yes. So what can we multiply to have 5? If we add, we have minus 6. The factors is minus 1 and minus 5. So that will give us p minus 1, p minus 5 is equals to 0. If you simplify from here, our p will give you 1 or 5. Right from there, our p will give you 1 or 5. Let's check the options. P should be 1 or 5. So which is option B? P equals to 1 or 5. So question 20, this is where we stop today. It says solve the equation x squared minus 4x minus 3 equals to 0. X squared minus 4x minus 3 equals to 0. X squared minus 4x minus 3 equals to 0. I cannot factorize this. What I will do is to impute the formula method that says x plus minus b plus minus b squared minus 4ac over 2a. So if you compare, just as we have been doing it, my b is minus 4, my a is 1, my c is minus 3. Follow the process. My b is minus 4, my a is 1, and my c is minus 3. So let's impute it. Minus into minus 4 plus minus 4 all squared, which is my b, 4 times 1 times minus 3 over 2 times 1. So minus minus there will give us plus. So we're going to have 4 plus minus 4 squared is 16 plus, why is it plus? Minus 4 times 1, that is minus 4. Minus 4 times minus 3, that will give us a plus 12. Plus of 12. 2 times 1 is 2. I'm going to have 4 plus minus square root of 28 divided by 2. 28, you can obtain a perfect square from 28, which is 4. So I will have this as 4 plus minus square root of 4 times 7 over 2. So if you look at the numerator, I can take the square root of 4 out. That will give us 2. 4 plus minus 2 root 7 over 2. So if you look at the numerator, 2 is common. I can factor out 2 from the numerator. I can factor out 2 from the numerator. That will give us 2 into 2 plus minus root 7 over 2. So 2 cancel 2. We are left with 2 plus minus root 7 as our value of x according to the question. So let's check which of the option is right. Let's check which of them is correct. So we are having 2 plus minus root 7, which is option B. So this is all we can take for today. If you have any question, you may ask before we make progress. And we might also fix another class. If you didn't enjoy this one because of the network and the break the transmissions, we can always fix another at your request. So you can ask any question you want. Any questions? So if there are no questions, we will inform you next. We are going to organize class for another aspect, either physics or chemistry or mathematics again. The other aspect of the maths, vector and vector, yes, vector in particular. We'll organize that again. Then we might also reorganize this if you didn't enjoy this one well enough. Afternoon, how are you?
Yes, sir. I just want to ask if there is going to be a complete video of this session, like maybe a YouTube video.
I can make, if you need it, I can make that available and send it to you if you want that.
All right. Yeah.
Okay, all right.
I would need it.
All right. Okay, all right. I will do that. Thank you.
Yes, sir.
Any further questions? All right. This is our YouTube channel, like I said earlier before we started, although you might not hear me. I will call it STEM Up Africa. We deal with computers, data processing, programming, what have you, mathematics, physics, chemistry, even technical drawing for those who are interested in technical drawing, among others, and engineering maths, engineering drawing, among other things. And AutoCAD, we also do into AutoCAD. So it's STEM Up, which is cover technology, engineering, maths, and science. So if you are not subscribed, please help us by subscribing. That's the only way you can support us. Thank you very much, you all. So I will leave it here. See you in our next class. I want to program it. We might get through to you through your class captain or your email. Thank you.
Hello?
Do you want to ask question?